Jupiter is one of the easiest planets to recognize. Even from far away, it looks finished, clean, striped, familiar. But that picture falls apart the moment you ask a simple question. If you drop toward Jupiter, what exactly would you hit? Not the clouds. Clouds are weather, not a surface like Earth. Jupiter does not give you one, and the deeper scientists looked, the stranger that answer became. Because Jupiter is not just a giant version of a normal planet. It is one of the clearest examples in the solar system that the textbook picture was too clean. The beautiful bands, the giant storm, the idea of a big ball of gas with a clear center inside it. That version is useful from a distance. Up close, it starts to fail. And the reason Jupiter is so fascinating is not just that it is big, it is that it is familiar in exactly the wrong way. We say gas giant and think we understand it. We do not. Jupiter is the largest planet in the solar system, with more than twice the mass of all the other planets combined. You could fit about 1,000 Earths inside it. But those numbers still do not really tell you what Jupiter is. They only tell you that it dominates the solar system by sheer size. The harder question is, what kind of world can get that large and still refuse to become simple? For a long time, Jupiter was mostly an image. A bright object in the night sky. Then a fuzzy disk in telescopes. Then, in the 1970s, the first close-up spacecraft pictures finally made it feel real. Pioneer and Voyager gave humanity its first intimate look at that striped globe, and the effect was powerful. Jupiter stopped being an abstract point of light and became a place. A real place. A spinning planet wrapped in storms. But those first images did something strange. They made Jupiter famous before they made it understood. Because a picture of Jupiter is not the same thing as a mental model of Jupiter. Those creamy cloud bands are not the planet, in the way a rocky landscape is the planet on Earth or Mars. They are just the outermost visible skin, a thin, beautiful layer on top of something far deeper, far hotter, and far less intuitive. And for years, that left scientists with a problem. The planet looked coherent, the inside did not. One of the older, cleaner ideas was that Jupiter formed around a dense core of rock and heavy material. Build the core first, then let gravity pull in enormous amounts of surrounding gas. That gives you a neat story and a neat diagram. Solid center, thick envelope, clear layers. It is a satisfying picture. Nature did not promise to respect it. The first great break in Jupiter's clean image came from a cosmic accident. In 1994, comet Shoemaker-Levy 9 slammed into Jupiter. Not in one piece, but in fragments. The impacts happened over several days, and for the first time, humanity got to watch a major collision with a giant planet unfold in real time. Dark scars bloomed across Jupiter's cloud tops. Plumes rose high above the atmosphere. A world that usually looked smooth and majestic suddenly looked wounded, and that alone would have been extraordinary. But the timing made it even better. NASA's Galileo spacecraft was already on its way to Jupiter. So while Earth-based observers and Hubble saw the aftermath rotate into view, Galileo had a direct vantage point during the event. It was one of those rare moments in space exploration that feels almost scripted. A once in thousands of years collision happening just as we had both the telescopes and the spacecraft to catch it. Jupiter did not calmly hand over its secrets. A comet forced the issue, and what followed mattered because Galileo was not just there to admire Jupiter, it was there to investigate it. Galileo arrived in the Jupiter system in 1995, and it also carried an atmospheric probe. That probe plunged into Jupiter's upper atmosphere and sampled conditions directly. But instead of closing the case on what Jupiter was like inside, it complicated the picture. The entry site turned out to be unusually dry compared with what many scientists had expected, reminding everyone of something important very early. Jupiter was not going to be understood from one pretty image, one clean diagram, or one local sample. That is the pattern that keeps repeating with Jupiter. Every better look gives you more detail and less simplicity. By the time the Juno mission arrived in 2016, the goal was no longer just to admire Jupiter, or even just to visit it. The goal was to measure past the image, to go after structure, depth, gravity. Magnetism, to stop treating Jupiter like a picture and start treating it like a planetary system hidden inside a planet. And Juno delivered one of the most important upgrades in our view of Jupiter. It showed that many of the features people thought they knew were not shallow decorations on top of a simple world. They were deep. Take the Great Red Spot. For centuries, it was the famous symbol of Jupiter, a red oval storm so large that Earth could fit inside it. That alone already sounds excessive. But Juno's measurements showed that the Great Red Spot is not just broad across the top, it also reaches roughly 500 kilometers down below the cloud tops. That means the most iconic feature on Jupiter is not some thin swirl painted onto the atmosphere, it is a deep structure, punching far into the planet below the visible weather. That matters because it changes the way you read the whole planet. The visible Jupiter is not the full Jupiter. It is the part your eyes are allowed to see. Below those cloud tops, the pressure rises, the temperature rises, and the rules you are used to carrying around from Earth start to become less helpful. This is where the phrase gas giant begins to mislead people. It is not completely wrong. Jupiter's outer visible layers are dominated by hydrogen and helium gas. But if you hear gas giant and imagine a huge airy ball that just gets denser on the way down, that picture fails badly. Because under enough pressure, hydrogen does not keep behaving like the kind of gas you are picturing. Imagine descending through a fog that gets thicker and thicker until it stops feeling like fog at all. Not because it got cold, but because the crushing weight above it forces the material into new behavior. Current models suggest that deep inside Jupiter, hydrogen passes into liquid forms, and deeper still, into metallic hydrogen, a state in which it can conduct electricity. That is one of the strangest popular science facts in the solar system. The most common element in the universe, the simplest one, squeezed so hard that it starts acting like a metal. Not metal in the everyday sense of a steel beam or a knife blade, but still something profoundly different from the gas most people imagine when they hear the word hydrogen. And this is one reason Jupiter is so hard to make intuitive. It takes the lightest element in the universe and puts it in conditions so extreme that your Earth instincts stop translating. What makes this even more interesting is that Jupiter's powerful magnetic field is tied to this deep conductive interior. Juno has shown that Jupiter's magnetism is also more irregular and complex than older, smoother pictures suggested. Even the invisible structures around the planet are refusing to stay neat. By this point, you might expect the story to finally settle down at the center. Maybe the outer layers are messy. Fine. Maybe the weather is deeper than expected. Fine. Maybe hydrogen behaves in bizarre ways under pressure. Fine. But surely the core is where the planet becomes clean again. That was the hope. And then, Jupiter took that away too. One of the biggest results from Juno is that Jupiter may not have the kind of compact, sharply defined core people once imagined. Instead, the data support the idea of a more diluted inner region, enriched with heavy elements spread out over a large fraction of the planet, rather than packed into one small, clear ball. In plain English, the center may not be a clean marble inside the planet. It may be more like a mixed inner zone, where the transition is broad and messy. That is a huge shift, because it means the deeper you go into Jupiter, the less you get rewarded with clean boundaries. Where does the atmosphere become the planet? Not cleanly. Where does fluid become something more extreme? Through transitions. Where does the outer planet give way to a simple core? Maybe it never does in the tidy way we hoped. Scientists have proposed explanations for this, including the possibility that a massive impact early in Jupiter's history may have stirred and diluted what was once a more compact core. But that is still model territory, not settled fact. It is one leading idea, not the final answer. And that uncertainty is important, because the best version of this story is not scientists used to be wrong and now we know everything. The best version is better than that. It is that each generation of measurements removed a layer of false confidence. The first images made Jupiter iconic. The impacts made it violent. Galileo made it complicated. Juno made it structurally strange. And even now, Jupiter is still not finished as a scientific object. Juno continues to return data, and recent work has refined even basic seeming properties, like Jupiter's shape and size. Meanwhile, future missions to the Jovian system, including ESA's JUICE, are part of the reason this story is still alive. We are not looking back on a solved world. We are watching an unfinished one. That may be the deepest reason Jupiter matters, not because it is merely big, not because it has a famous storm, not even because it may contain metallic hydrogen. Jupiter matters because it exposes a weakness in the way we like to think. We like categories: gas, liquid, core, atmosphere, surface. We like planets that can be drawn with a clean cutaway and a few labels. But Jupiter keeps turning those labels into gradients. The clouds are real, but they are not the whole planet. The descent is real, but it does not give you a satisfying landing. The center is real, but it may not resolve into the sharp object we expected. Jupiter is not confusing because nobody has looked. Jupiter is confusing because reality is under no obligation to arrange itself into the boxes that feel easiest to teach. And once you see Jupiter that way, it changes more than one planet. It changes how you look at the universe. Because now the question is not just what Jupiter is. The question is, how many other familiar things in space only look simple because we have not measured deeply enough yet? That is what makes Jupiter so good. It starts as one of the most recognizable objects in the solar system, and ends as a reminder that the universe is stranger than the clean version we carry around in our heads. Jupiter is not just a giant planet. It is a giant warning against mistaking a beautiful surface for understanding.